Okay, so here are some practice problems on using the quadratic formula to solve a quadratic. So the point of solving a quadratic is to find the x-intercepts. Now we have done this by using basic factoring and using the zero product property to solve for x. We've also learned how to complete the square if we need to basically force this equation to be somewhat factorable, right, in order to find the x-intercepts. But sometimes neither basic factoring and zero product property nor completing the square works, okay? So this is a formula that I will one day make a proof for, I promise you. It's x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is the quadratic formula, okay? And this works every time as long as you do it right. So here we would plug in the b term, and here the b term, and here we'd plug in a, and here we'd plug in a, and then here we'd plug in c. And what this is based off of is that the standard equation of a quadratic, the standard form is ax squared plus bx plus c. And in order to use the quadratic formula, we have to make sure it's equal to 0. So all of the terms have to be on the left-hand side. So this is the c term. It's sign and everything. So if it's negative, then c is negative, and so on. This is the b. It's the coefficient of the x, whereas the c is the constant term. And the a is the coefficient of x squared. So let's go ahead and give it a shot. So before we get started, I need to emphasize that your first step is to always solve for a, b, and c. Okay, so I'm going to start highlighting. I see here in my equation, my a is 6. Okay, so a here is going to be 6. My b is negative 9. And you always have to make sure that like the variables are in the right order and everything before you get started. And after I do this basic example, I'll go down and do some of the more difficult ones where you have to do other steps first. And then here C is negative 162. Okay. So, negative 162, that's a big number. Okay, so here's what we do. We are going to start plugging this in to the quadratic formula. So I'm going to zoom in a little bit. I have it memorized, so hopefully you wrote this formula down. If not, you should pause it first because it's going to disappear. Okay, I'm going to make this stuff a little bit smaller now that I'm zoomed in. So we have x equals negative b, and what I'm going to do here is I'm just going to do the color there, okay? Negative b plus or minus the square root of b squared. Let me make this guy a little bit smaller. There we go. Of b squared minus 4 times a times, the c is longer, c. I know that my c here is negative 162, so it's going to be a big number. And this is all over, the entire thing is over 2 times a. So this is just the formula, and now you have to plug in your numbers. So here, if a is 6, I'm going to put a 6 into both places where my a needs to go. B is negative 9, so I'm going to put a negative 9 into both of these places. And C is negative 162. Okay? And you guys notice here that these are actually n's, and that's okay. Technically then, this would be that n equals this whole formula, but we're solving for the x-intercept. So I think a lot of you just naturally write x, and that's totally fine. As long as you understand that in this function, n is representing what x normally does. So we'll leave it as n just because that's the variable that's being used in this problem. So now our next step is to simplify. So you can either simplify, go straight down, or you can write it next to it. I don't really mind either way personally. So here we have a negative times negative 9. This is technically just a negative 1 times negative 9. So that would be a positive 9. Plus or minus, this here is a negative 9 squared. So that's negative 9 times negative 9, which is 81. So right here, negative 9 squared is positive 81. And then right here we have negative 4 times 6 times negative 16. So do this all at once. And I'm just going to do this little drawing here just to show you that number is what we get here. So I need a calculator for this. So if we do negative 4 times 6 times negative 164. Let me go make sure that that's right. I don't think that's right. Oh, I did plus 6 times 6. There we go. So negative 4 times 6 times negative 16. Oh wait, negative 164. Oh my gosh, am I tired or what? 162. I'm coming up with numbers here. You're probably like, wow, my teacher's crazy. Negative 162. Oh my goodness. This is why I should stop working at a certain time of night. So we get 3,888. And some of you might be wondering why I didn't use parentheses. It's the same thing. So if I had negative 4 times 6 times negative 162, you'll get the same thing. But you see, I might not have made the mistake of writing the plus sign instead of the multiplication if I had been using parentheses, right? So we have 3,888, and it's a positive here. All over 2 times 6 is 12. So now I'm just going to go and write it over here. So we have 9 plus or minus the square root . I'm just going to write n equals again. We have to do 81 plus 3,888. So we got to simplify that. So back to my calculator, I can take 3,888 plus, what was that number in there? Plus 81. 3,969. Okay, so now I know that the inside here is 3,969, and this is all over 12. So what you want to do first is see, is this a square root? Is that a perfect square? So what we want to do is we want to go back to the calculator and try to take the square root of that number. Okay, so we're going to do the square root, and then you guys can honestly just push the answer button, and it'll bring up the previous answer there. You could definitely just type it out, but just to save you time, you could always just write the answer. 63. It is a perfect square because 63 times 63 is 3,969. 63 squared is 3,969, right? So that makes sense that the square root of 3,969 is 63. Okay, so what we're going to do is write 63. So this square root equals, so this is 9 plus or minus 63, right there, all over 12. There's no square root sign or anything because we took the square root of 3,969 to get 63. So now it's just 63. And you can see that on the calculator too. So that answer became this one. And now we can split it. So now is the time where we take these two and we split them. So I'm just going to write split for you. Okay, so we're going to have, n, I almost wrote x again. N equals 9 plus 63 all over 12. And n equals 9 minus 63 all over 12. Now, you can plug this directly into your calculator, but you have to be sure to put parentheses on the top. Okay? If you don't, you should just do them piece by piece, like one at a time. So like here, I would do 9 plus 63 is 72 all over 12, which is 6. Okay, so I'll show you how you can still get that without adding the top first. So if we did, man, I have a bad memory tonight, 9 plus 63 in parentheses, and then divide by 12, you get 6. You guys could have also done 9 plus 63, you would have gotten 72, and then done 72 divided by 12, you get 6. Okay, so either way works, but this is the way that does not work. If you do not have parentheses and you just do it like that, the 9 is not being divided by the 12. Okay, so that does not work. You see that? So this one is bad, but the others are great. Okay, so you should get 6 for that one. So now we can also do 9 minus 63 divided by 12, and you get negative 4.5. Okay, that's because 9 minus 63 is negative 54. So this is negative 54 divided by 12, which equals negative 4.5. So these are your two answers. You have exact answers for this one because that was a perfect square over there. The 3,969, the square root of that is 63. Okay, so now you know n equals 6 and n equals negative 4.5. All right. So make sure you pause the video if you missed any of that. Oh, just to emphasize too. So this is where we had split the plus and minus right there, just so you don't forget. All right, let's do one where you have to set it up into standard form. Okay, so I'm just going to do a few of these, and then I'll solve one all the way through. So I need this to be in standard form. Let me go ahead and take a screenshot or copy this guy over. Copy. All right, so we need to always be in standard form. This is standard form right here, okay? That's what we need to be in order to use the quadratic formula. This is what is the quadratic formula. It's a formula for quadratics to solve the x-intercepts, okay? All right, so over here, this is not equal to 0. I need this equal to 0. So we need to subtract 2 from both sides here. And I can only subtract the 2 from the 1 because those two are constants. So it cancels out on the right. And we get 4v squared plus 3v minus 1 equals 0. So what we can do here is practice stating A, B, and C. That's the most important part. And then you just have to kind of plug everything in. So here, we have A, B, and C. So what I want you to do is try this on your own, pause the video, and try to determine A, B, and C according to the standard form over here. Assuming you paused. Okay, so the V squared, the A term is its coefficient. B is 3, because that's the V's coefficient. And the negative 1 is our constant. So A is 4, B is 3, C is negative 1. And then you're going to plug that into your formula, okay? So I'll go ahead and set this formula up for you. You know what? Here, I'm going to do something that'll kind of help this video go by faster. Okay, and then I'm going to add some colors here. So that's the C, the B is here, B is here, and A. Okay, so I'm going to make a few copies of this. Copy, paste. Okay. And this as well. All right. Okay, so we always want to remember the standard form is ax squared plus bx plus c. Even if it's a different variable, it's fine. So for this one, what I would do is I'd plug in 3 here, 3 here, it's positive 3 as well, 4, negative 1, 4. And then you would start to simplify. So I'm not going to go through the simplifying part. First, I'm just going to set up all of these equations, okay? Because we simplified up above. It's the same strategies. It's really just making sure you know how to add, subtract, multiply, divide, follow the rules of exponents, all that stuff. Whoop, sorry about that. Okay. So number 6 here, it is not in standard form. So what we have to do here is rewrite that equation. So I'm going to kind of get that one out of the way for now. The first thing I would do is draw a line down the equal sign because it looks like we're going to have to do some work here. I'm going to subtract 7 from both sides. I can combine that with the negative 65. So now I have 2p squared minus 72 equals 0. This is still not in standard form. We are missing this middle term here, the term with only one variable. So what we have to do here is we have to put it in, but it is 0 of the variable, 0p, or it would have been 0x. So you have to have that there so that you're able to identify the a, b, and c. So a here is 2, b here is 0, and c is negative 72. So 2, 0, negative 72. Okay, so again, just make sure you're pausing if this is going too fast. So over here I have my equation, okay, my quadratic formula. So my b is 0, 0, 2, 2, and then negative 72 for the c. Oh, I wrote too big there. Negative 72. So I'm going to simplify this one just so you can see what happens whenever you have a b that's 0 or maybe even any other number that's 0. Okay, so we're going to simplify this. X equals, well, negative times 0 is 0. So this plus or minus doesn't really end up being anything there. So we're just going to put, well, we'll leave the 0 though. 0 plus or minus the square root. So we have 0 squared is 0. And then negative 4 times 2 times 72, that's 72 times 8. 6, 1, 7, 576. So 0 plus 576 all over 4. All right, so this is 0 plus or minus square root of 576. So we still have to keep that plus or minus because if we still have the square root there, no matter what, we have to have a plus or minus out in front. So that's why I kept the 0 just so you can see how it stays. Let's see if 576 is a perfect square. The square root of 576 is 24. So that's perfect. So what I can rewrite here is x equals 0 plus or minus 24 all over 4. And now I can split it. Okay, so I'm going to make this top part just a little bit smaller for me, kind of in the way. All right, so we're going to split the plus and minus here. So we're going to have x, oh, I started to use x, it's really p, but it's okay, I won't dock you guys points on that type of stuff with variables. So x equals 0 plus 24 all over 4, and x equals 0 minus 24 all over 4. Okay, you guys know me, this bugs me. I'm going to change all these to p's since I didn't realize it before. It's the perfectionist in me. So this variable in this problem is p, not x. My bad. All right, so now we can simplify. So 0 plus 24 is 24. All over 4 is 6. 0 minus 24 is negative 24. All over 4, negative 6. So p equals 6 or p equals negative 6. So that's where Your quadratic formula would be true if you were to plug that in for the variable, and that is where your quadratic is going to pass through the x-axis. So those are your x-intercepts there. Okay, so again, pause the video, get all that down. So let's go and see how I would have to set this one up here, okay? So here I need to, let's just go and draw the line. So my first step is I got to add 12 to both sides because I need it equal to 0. These two are like terms. So now I'm going to have 5v squared, and I notice right away I do not have a b term. So I'm going to write plus 0v, negative 14 plus 12 is negative 2, 0. Okay, so now if we go through identifying, 5 is a, our b is 0 because it was not existent, but we had to have it there. C is negative 2. So we have 5, 0, and negative 2. So now if we go ahead and plug this in, negative b is negative 0, plus or minus the square root of b squared would be 0 squared, minus 4 times a times c, so minus 4 times 5 times negative 2, all over 2 times 5. And then you can simplify just like we did up above, okay? Now I want to show you guys that you can be checking your answers down below. Okay, I provided this to you with your answer. So this is basically what this says here. With the brackets, this says x equals 6 and x equals negative 9/2, which is, if you were to divide that, you get negative 4.5, which is how we wrote ours. We wrote ours as a decimal. Okay, so this is saying x is 7 and x is negative 2. Since these are the squiggly brackets, it's not saying that it's the 0.7 negative 2 on the graph. That's not what this is saying. It's just saying that those are your two answers right there. Okay, and so on and so forth. Do not worry about number 9 because that one is an imaginary number that I have not taught you yet. So you do not have to do that one. And same thing with number 11. Do not worry about number 11. But if you want to do well on the EST, this is a good practice sheet here to try. So you can continue to use my notes. I'm going to leave number 8 blank like that just so, actually here, I'm going to put this everywhere because I want you guys to use it every single time, okay? Feel free to do this on a separate piece of paper. This is totally up to you. If you do some of the problems, you will get better, right? Oh, I forgot which ones did I cancel out. 9 and 11. Okay, so not 9 and not 11. So you do not have to do these two because they are imaginary. They do not work right now. You'll get a negative underneath the square root, and that is no good, okay? So continue working on this and see how you do with the quadratic formula. There's a bunch of videos online as well. So once you get done watching this one, you can go ahead and find more online, how to use the quadratic formula. I'm losing my voice now, so I am all done for the night, but I hope this video helped you prepare.